Welcome back. We're watching Centerline Designs, and today we're building a 100% stainless steel rocket stove water heater. It's going to be a pretty cool build. It's been something that's been on my mind for a while. I don't know why, but trying to heat up water is kind of a fun thing. I love having my redneck hot tubs. So today I want to take you through the full build video of creating this little 2.5 gallon rocket stove water heater. I think it's going to be a pretty fun build. We have everything from CNC plasma cutting to a absolute ton of stainless steel TIG welding. Definitely a learning curve for me, being that I'm primarily an aluminum guy, but I think you're going to really enjoy it. And yeah, give me a thumbs up, drop a comment if you like the video. All right, let's get to it. Alright, well, after washing all the parts, I just laid them out here and they dried over the last few days. So let's get all that up onto the table, and I plan on working on putting it all together. Alright, well, I'm pretty much all set up. I am back using my Yes Welder CT 2050 on this one. I'm going to be playing around to start, get my settings dialed in with some of my test plasma cut pieces. I'm thinking I'm probably going to wind up using pulse on this. I don't do a lot of stainless welding. I'm mainly an aluminum guy, but I like learning. And, you know, all this is all just about having fun and hopefully build something pretty cool. So, with that being said, I'll get welding and hope you have some fun watching me start piecing all this together. Not too bad. It's definitely a little bit of a learning curve for me, but cool. Well, the battery died there, but as you can see, it's coming along really nicely. It's hard to show close-ups. I'll try and use my phone to get a little better close-up for you there. You know, I'm not the best stainless TIG welder, but you know, it's coming along. It's not all sugary or anything like that, so I think I can live with that. So this is going to be the body of the rocket stove. There'll be an ashtray and everything in here, and a little bit of a grating to hold the coals up. This would be an air inlet. There'll be a damper. The wood would feed in here with a lid, and then normally this would be taller and you'd put a grill on it or something, but this is where the water jacket is now going to sit on top of here. So that's going to be the next part I start making. I have to leave that part separate until I get the tubes in and everything like that and actually create the watertight jacket. But we can start assembling some parts and get a better idea of what it's going to look like. All right, well, things are coming along pretty well. I needed to go in, get a bite to eat, cup of coffee. I cut out a grill pattern that's gonna go in, and the wood will fall on that and let the ash fall through, but hold the coals up nicely in the air. And then on the actual stove itself, it's turning out really nice. I'm pretty happy with it. I screwed up. I didn't mean for this to be a flat flange. I had originally planned it to be a taper, like 45 degrees, and then go up into the 8-inch and then 45 back. But I clearly did my design wrong, and I realized that, and I went ahead and put it together anyways because I figured the bottom won't matter too much. I'm gonna put a little bit of a heat deflector inside here to try and spread the flames out a little bit so they more evenly go through all the boiler tubing. But the top side, I didn't want flat. So I redrew my taper pieces here so that it'll have a little bit more aesthetics on the top. Bottom, that is what it is. But yeah, so, you know, things don't always go exactly as, things don't always go exactly as you plan. Pretty happy with this. Again, not quite what I imagined. I kind of imagined more something like that, but oh well, what are you gonna do? I didn't feel like wasting material to recut this. However, I did on the top, so. Oh well, this is kind of a proof of concept. It is thinner stainless. It's 16 gauge, so which is I think 60 thou. So it is pretty thin. I'm well aware that it's probably gonna warp and deflect in certain ways, but I'd rather make this out of 60 thou rather than my 100 thou sheet because, well, stainless is pretty expensive. So if it's not gonna work, I'd rather waste as little money as possible, but it's gonna work because I'm not gonna stop until it does. But enough talking, let's get, I put little tabs on here, so I'll bend the tabs down and then I can make sure every tab fits, and I'm just gonna tack it into place and then we'll put a little bend. I'll kind of show you what I'm doing there, but let's go do a little bending. Perfect. I'm just gonna bend these tabs by hand, just knock them over with the hammer a little bit because they're way too small to fit in here. So that'll be a nice little coal grate. All right, there you go. There's where the wood goes down in. Nice grate. There'll be that damper door in here, and the ash will fall down into an ashtray. And fits pretty good. I've got it kind of tweaked a little bit right now to get the front tacked in, and then I'll straighten up this back so it's not so ugly, and get some tacks in on all these little tabs here as well. It's pretty hard to bring you inside here for video this. it took a little extra massaging, a little bit of hammer strikes on the side of the table to tighten the curve up, because that press brake's just pretty hard to be accurate. I guess if I spent the time with a test piece, I could dial it in, but I didn't. Eventually, I'm going to get myself a really nice box pan brake, but for now, it works. There is an ashtray. A little bit more massaging to do on this, and we'll put the end on, and yeah. Well, I don't have any stainless hinges to weld on, so I have a nice little aluminum hinge, which will be fine, won't rust. I think it's got some paint on it, but that'll burn off if it gets real hot. This is going to be for the fuel door, so we'll just drill this and bolt it on. There. That'll serve the purpose. I did a little test cut with some different diameter holes, and in my test cut, I did find that the pipe fit into it fairly well. But when I went and cut these holes, they were just a tad on the small side. So open them up. I think it's going to work out quite well. And if you can see this, this is my idea. I have a top and bottom plate, and all these pieces of pipe are going to be inside, and the fire is going to come up through the pipe. So the surface area that the fire will have in contact with the water is going to be quite large. And my understanding is that's basically what it comes down to. The type of the material and how good it is at conducting heat. Copper is much better than stainless. I forget the number, I had looked it up, but it's significantly better at transferring the heat from the fire to the water. Stainless is not as good, but stainless is a cheaper material to work with and a bit easier for what we're doing here. If I was to make this completely out of copper, I'd never be able to have a fire in it without water in the jacket. With this being stainless, I'm fairly confident that even without water in here, it will be fine. The stainless is going to heat up. It might warp and deform a bit, but I don't suspect it would cause any holes or leaking or anything like that. So I believe I have everything prepped. So now we're basically going to start assembly of the water jacket. Right. Alrighty, we are mostly done welding now. The water jacket, I think, is pretty much done. It turned out pretty good. Really nice. The only problem I had were in some of these corners. There's a little bit of gaps and I had problem filling them in. But other than that, I'm really happy. We got all these tubes. Most of the tubes were all done with just a fusion weld. I had to add very, very little filler. I went ahead and got the inlet outlet on there, and yeah, I think now what we need to do is rig this up, and let's do a little air test on it. I'm going to put, I don't know, 4 or 5 pounds of air in it and check it for leak down, and if it passes, then we're going to finish assembly. Well, we got a slow leak. I can hear it. I think it's coming from the underside. But let's soak this up. One there. Well, I am really happy with how this is turning out. I went ahead and I put a nice little handle on the door, and we got the damper in place. You can see all the boiler tubes, our inlet and our outlet. Alright, well, the only other thing left to do with this is make a stand for it to sit on, get it off the ground a little bit. So I'm going to flip over and you do a little bit of aluminum work for that, because I don't really have a lot of stainless other than some sheets, and I have tons of aluminum because this is mainly what I do here in my shop. So we're going to go ahead, make some nice little legs, and make it clamp onto the stove, and then I think we can pretty much call this project complete. And I'll get to testing it, but you will have probably seen that already. So anyways, let's finish up the last part and call it complete, which is pretty exciting. I was hoping this to be a one-day project, but like everything I do, it takes significantly longer than I anticipate. But that's all right. Let's get to it. Well, I think it's done. Even got my logo in there. Very nice. Well, I really hope that you enjoyed this build. You know, it wasn't working on the Snowcat like I normally do, but this was just another thing I had in my head, and I wanted to take some time and make something different. So hopefully you enjoyed it. Again, we've got lots of things planned. I just need to have the ambition to do them. But hope you enjoyed it, and yeah, we'll see you in the next one. Thanks a lot for watching.